Hello, everyone. Thank you so much for coming. My name is Elliott Frisch. I'm going to be giving my talk on Anyhow Turbofish using VS Code for Rust development and debugging. It's really about three different versions of the same code, and then a fourth one that's actually doing something real productive. But just a little bit about me. Again, my name is Elliott Frisch. I work for JFrog. Our core competency is helping developers leap forward. I've been developing for 20 years and working in Rust for about a year now. Prior to that, I was a system administrator, so I have a lot of background in DevOps. The QR code is to the link, which is at the bottom, which is all the code that I'm about to share during the talk. So it'll take you straight to the GitHub if you're interested. And I will be bringing this slide back after the talk, or actually a similar slide, but there's a slide at the end where I reiterate the links. So if you missed this, it's fine. It'll be back. When I was first starting with Rust, one of the things that I really struggled with, or that I initially needed to do even, was just make a REST API call. And one of the things that I first ran into is when you want to do a lot of things in Rust, it seems like it requires that you be very explicit. And the specific example I'm giving here is we're going to parse this very, very simple JSON, which is just a version and floating point value that happens to be represented as a string, because unfortunately a lot of JavaScript people decide that floats should be strings. At least that's been my experience. Perhaps your experience will be different. I hope it is. So when you get a JSON value in Rust, it represents it as an enum type of JSON value. And in order to do anything interesting with that, you actually need to match against the value and determine whether it's a string, whether it's a number, whether it's a short. You can tell, or whether it was just something else entirely that was unexpected. And this was the kind of code that I first wrote when I started writing Rust, in terms of, okay, I'm going to explicitly match every single condition, because otherwise I'm going to get a compiler error. And obviously this was very, very verbose, and it doesn't really do a whole lot for what it is, and I am going to run it. So you can see, it just says, oh, I parsed version 0.8, and I'm like this bigger because there. Can everybody see that? Awesome. Like I was saying, if you simply change this to say, let's make it something that isn't a floating point value. And we can run it, and you'll see, hey, I get a parse exception of a kind empty. So, I mean, the code works. It just doesn't do a whole lot, and it's rather a lot of it just to parse a floating point number. So that brought me to this version, which was version 2, where I learned about Anyhow. Anyhow is an interesting Rust crate in that it allows you to idiomatically enclose errors, and it does this through the addition of the question mark operator. You'll notice instead of being an STD result, now it's an anyhow result, and I'm not returning a specific error because anyhow lets you omit the error code. This is a lot easier, it's a lot simpler, and if we run it, you'll see it does exactly the same thing as the first version did. Only I don't have all that boilerplate anymore. which was a lot nicer. And in fact, if I just, again, run it with something invalid, it says, oh, I can't parse that, it's an empty string. So the code still does the same things, still behaves the same way, but now, instead of pages of code, I've got a tiny, tiny little bit of code. It does functionally the same thing. Also, part of the talk, which I meant to mention earlier, this is called the Turbofish, if you've never seen it. When you parse something, the syntax of colon, colon, less than, and then the data type greater than is called the Turbofish. And it's the way you can hint to the compiler the type that this is expected to return. So that made it a lot easier, a lot better. And then I decided I needed to go to the next level. And the next level is, let's actually hit a URL and parse the value out of it. So what you're seeing here is I've got a hard-coded URL that's going to hit version JSON. It's going to make a request. It's going to call getJSON, which is going to do a request blocking get the text of that. Again, using anyhow on all of the possible error matches so that it's going to automatically percolate the errors up. And then we're going to parse the result, again, to a floating point 32-bit value. And here, if I run it right now, it'll fail because I don't have the web server up. But I'll just show you that real quick. And then I'll bring the web server up and see that it works. And then we'll do one or two more things. So let's see what this does. I don't know why it's being... OK, there we go. So could not parse version, error sending request for the URL, error trying to connect. So that's kind of what you would expect, I would think, when the user tries to hit something that isn't there. So now, I'm going to bring up a web server. I've got a static JSON file in this folder, and now I can run this code, and you can see I get back 3.14, which happens to be in this JSON folder. So I'll change it to something else. So that just works. Yay. So this was about where I'd originally planned to wrap things up. But after sharing this with Cole, he challenged me to go another step. So I did. And the very last step, and this is the version we're going to spend the most time on probably, was actually make a real API call to something called Zipopotamus, which is just a public REST API. You give it a zip code, and it gives you back a bunch of things, but among them are city and state and latitude and longitude. And just for giggles, I went ahead and wired that in. So first I'll walk through. We have to have structs to represent the data types that's going to be coming back from the API call. In this case, every zip result has a collection of places. It could be one, it could be many, because one zip code could match to multiple cities, it turns out, which is kind of interesting. Probably not in the US, but this API supports international. We're going to parse out latitude and longitude, state, city, all that kind of good stuff. And the way we're going to do that is we're going to hit this Zipopotamus API. We're going to pass it a zip code. And then once I get the latitude and longitude, which I'm parsing here, I'm going to build a Google Maps URL so that you can just click on it and see where that is. And so, just again for giggles, I made it default to 96943. Is anybody familiar with that zip code? Be really shocked if we had anybody here from Yap. It's the island of Yap in Micronesia. Kind of random, isn't it? But it's a U.S. territory.
And how's it spelled?
Yap, Y-A-P. So if I just run this now, it's going to go out there and you'll see that is 943 is United States, Yap, latitude and longitude, federated Micronesia. And if I go to that Google URL for the Google Maps, we get a lovely beach. And it's in the middle of the ocean. But yeah, this is the, yeah, it really is. It's the island of Yap. And I just threw that in there because I thought it was amusing. But we can also, 90210, which is Beverly Hills, California. And so, you know, obviously we have a fully connected API. We're getting latitude and longitude from zip codes, and we can get the corresponding Google map for it. All this code is obviously up on GitHub. I gave the link at the beginning, but I will reiterate it. So, where did I put it? Oh, it's in another window, that's why. Sorry. Anybody have any questions?
So it was the anyhow macro that translated a standard?
So the anyhow macro is what lets you avoid doing all the matching code. So if we go back to version 1, that's really the only place where I'm not using anyhow. So you see how I'm doing all these various matches? You know, did I get a value? Was it successfully parsed? If it wasn't successfully parsed, I want to go into this error match. And if it was, then I'm going to just proceed and return OK. Well, what anyhow allows you to do is skip the error matching and just bubbles the errors up automatically.
Oh.
Yes?
So I think in the next example, you're actually using anyhow for wrapping errors. This one doesn't need anyhow for that. Because anyhow just uses the error trait to make it so that you can easily treat different types of errors as a unified error type.
That is a good distinction, yes. So what he's saying is, yes, it is correct in that anyhow also sublimates all the various types of errors that could be and allows you to just percolate them all up as one type of anyhow error instead of some other kind of error.
Like I think V3 shows it well with the request stuff. The 1-2 transformation is mostly just a refactor.
Yes, correct. Again, the original intention was to show the evolution of make the most boring basic request to a REST API, get some value back, and parse it.
Line 24 is where the magic happens.
Yeah, I want to ask how that works too, because it looks like you're returning an anyhow result with type of JSON value, but you've got a question mark by the get for request blocking, which presumably returns some kind of HTTP error.
It'll either return some kind of HTTP error or it'll return the string of the body of the HTTP response. But if it does return an error, then the anyhow macro is what's going to allow that to just populate back up. And instead of panicking, right? Because the other alternative would be to just panic. And that's really not a good idea usually.
But anyhow has some way to convert the error side of that result from whatever kind of HTTP error to a JSON value?
No. So what's happening there is it's still going to the error matcher, but it's happening to the match on line 7.
What anyhow is doing for you is it's providing a type wrapper for the error trait, so that both the request error and the JSON parsing error can be treated as a generic error.
And the other thing, if you'll notice, is the difference between an anyhow result and a standard result is a standard result, you provide 2 types. You provide the good type and the error type.
Oh, I see. The JSON value is the OK type, not the error type.
Correct.
Well, the JSON parse can also return a JSON error. The key here is anyhow provides a generic, like dynamic error.
Yeah.
Effectively, you have hidden in there, you have a dyne trait.
Yeah. So like you'll see here, if I had a parse float error, I have to pass that back as some other kind of error. Because if I don't, then it'll just panic. So that's why the code went through that transformation. And yes, that's all anyhow is giving you, is not having to explicitly match all of the error all the error branches when there are multiple error branches that are possible within a method, which is generally every method. Yes?
How much of a pain in the butt is it to downcast an anyhow error and get the original error type out? So let's say, for example, as we've been discussing, you make an HTTP request and there's an HTTP error. Anyhow swallows that up and says, hey, this is an anyhow error now. You don't have to think about it. You just deal with it later. What if I actually want the contents of that HTTP error?
Well, you can. You would format it and put whatever you want into the format. So like here, when I'm getting the
Yeah, on line 15.
yeah, on
Yeah,
line-
but that's one line, and that error could be 9 different error types. 'Cause it's dynamic, right?
no, look at line 27 too.
Okay, I see.
Yeah, and line 34, and line 41.
So he was talking about anyhow errors though, not these
Yeah,
three errors.
you can't unpack it. Anyhow is recommended for binaries, not for libraries for that specific reason.
Because there's no,
Because
You can't unwind it. Yeah.
Because
so you just do pattern match on the trait type, the error trait.
Well, if you wanted to,
does it keep the contained parameter?
It has a downcast.
As any
It has a downcast function, but it's like that.
So that's why like this error is generally.
well, and generally you don't even really care, right? Like some error happened. I don't care what error. I just need to handle it and move on gracefully. Generally, I mean, sometimes you do, perhaps, but
You need to log it. Kind of need to log it, and then.
yeah, log it, throw another exception, or just wrap it so that you get the important messages back. So like I was parsing something and here's what happened, or here's the value I was trying to parse and here's why it failed. I mean, you can capture all that information and log it, or just even format your own errors, however you want to do it. The other thing is, of course, you are going to lose like what line it occurred on unless you do your own backtrace.
Is anyhow built on top of Saturday? Would you use both of them together?
You certainly could. I don't believe they're built on top of each other, but anyhow's its standalone crate, and I believe Surday probably uses it. Wouldn't shock me if they do.
Yeah, I don't think Surday uses it directly.
But you could certainly use it with Surday, because we do.
I use it all the time.
Yes?
For getting information back out of the diner, there's some new RFCs and work being done to help enable that, and also move parent decor. There's like a provide context API being added, so that's how you get back traces while still being able to put it in the car. And you can also use that for other stuff. And those type ID is
Okay, so you like look it up by type ID and it gives you like an option whether or not it's at that type or something.
The downcast API anyhow works with the Turbofish. You tell it what type you want, and it just gives you an option.
Yeah,
So it's essentially
that makes sense.
Yeah. Any other questions? Awesome. Yes?
Maybe a naive question. So let's say you're getting back places, right? So you have your struct, and all of a sudden my API starts giving me arrays. How would you think about maybe V5 of that, or continue to?
And point of fact, this code is expecting arrays for places. If you actually look at,
So like the root object itself, would you like make a new struct and say like?
yeah, what I would do is I'd make a vec and just start adding the values from the array to the vec, but that's just me. You certainly could make it a statically sized array because Rust will let you do that. But the easiest thing to do, and that's what I did here, is I just put it all into a vec. So if you look at places R here, that's a vec of place.
So here's another question. So let's just take this like nested object, the zip code with plate with latitude, longitude, and an array of places, and I want to get like many of these. How would you design this that, let's say you made, your API gave you like 100 of these objects, but your parser was only designed to match 90 of them. I want to raise error, I want to log 10 of those errors, but keep those 90.
Then what you would need to,
Restate the question.
I'm sorry?
Could you restate the question?
So it sounds like what he's asking is if you want to bound the size of the array, and limit it to a specific maximum. And you could certainly do that by, for example, in this code, only iterating for 0 to the minimum of the JSON value length of the array, or the 90 in that case. So that would just be a simple math.min of the, or just a minimum of the two. Yes?
So I heard somebody else mention anyhow is not good for libraries because you can't unroll. A little more generally, would you recommend anyhow for production? If not, what would you recommend instead?
I very much would recommend anyhow for production. I think the distinction that's being made there is if you're writing a library, they don't really recommend that you embed anyhow within your library. But if you're using a library, I would highly recommend anyhow, because it very much makes your life a lot easier. Like I said, when I originally started using Rust, I did everything with explicit matches on every handle, because otherwise I was getting compiler errors, because that's how everybody starts with Rust.
I love anyhow for side projects. I just wonder if there's a catch, you know.
I mean, there's limitations to everything. No tool is perfect for every situation. So, like we've discussed earlier, libraries are a good place where anyhow is just not a great match. But you know, I'm not going to say that's universally true either. I mean, you could potentially write a library where it would make perfect sense to embed anyhow. So, I mean, you got to love software development. There are no.
It's situational.
Yeah, there are no hard rules other than it needs to be faster and cheaper. However fast and cheap it is, it needs to be faster and cheaper still. That's the only real rule of software development.
Okay, thank you.
Yeah, no worries.
Maybe one more question?
Any other questions?
Can you just clarify the purpose of the Turbofish?
Oh, yes. I mentioned that in parse and very quickly, but the Turbofish is how you hint to the compiler. The Rust compiler is very good, but unless you want to explicitly type everywhere everything, when you're parsing something, you generally need to give it a hint to tell it what you expect to come back. And in this case, you use a Turbofish, which is this : less than, and then a data type greater than. That is the Turbofish operator, and it returns a option type, or a result type, I can't remember, but it returns an optional type, which is why I'm combining it with the anyhow question mark operator there. Because basically what I'm saying is parse this to a floating point 64-bit value, and if it fails, just percolate the error up. Don't make me explicitly handle that here.
Another way of saying that is Turbofish lets you provide generic parameters explicitly. So in this case, parse has a return type generic parameter.
And so you tell the compiler what type you want. You could also do that by saying latitude : F64.
Yeah, and that would be the other option, but even then, sometimes it doesn't.
It's strict either way. This basically either way it says try to parse this as a 64-bit float and return a result that's an error if it can't parse it as a 64-bit float.
Yes, but it does all of that internally, whereas if you just said latitude : result F64, then you would have to match on the result to see if you successfully parsed it or not.
Well, you could say F64 and keep the question mark.
Yeah, or you could do I think you could say F64 without the question mark and then do or _ error, I think, is another option. Like you can map an error is the other way you can do it. There's so many ways you can do everything in Rust, so it's kind of nice that way, but yeah. So I hope everybody got value out of this talk, and just a real quick wrap up. I've been working on Persia, which is an open source distributed Rust-based service for securing the software supply chain. We're doing peer-to-peer, non-repudiatable builds within a distributed network. And it's all about securing the software supply chain. So Obviously, we could use more help, so if anybody's interested, we're at Persha.io, and like I said, we're open source. And then a couple more links, just for me personally, if you want to get in touch. And again, for the source code for the presentation is on the QR code there. So I'll turn it back over to you, Cole.